So question 11 is very similar to question 10, except there's a lot more work. It says determining the limiting reagent and the mass in grams of nitrogen that can be formed from 50 grams of N2O4 and 45 grams of N2H4. And then it gives us some useful molar masses. So essentially here, we're given a mass of both of our reactants, and we're asked how much nitrogen we can form from both of our reactants. Well, this is a limiting reagent problem. What we're essentially doing in a limiting reagent problem is we're figuring out how much N2 we can make with all of this and how much N2 we can make with all of this. And whichever amount of N2 is less is how much we actually make. Why? Because let's say this one gives us less N2. Well, that means this is gone. If this is gone, we can't possibly make more N2. And please know, I'm totally making that up. I haven't solved it yet, so I don't know which one is the limiting reagent. I have to do the math. So if you didn't watch the previous question, I would strongly recommend you watch that first. But in this case, I'm going to go with two plans of attacks. So I'm going to start with N2O4 because it comes first. I'm going to convert from grams of N2O4 to moles of N2O4. Then I can convert to moles of N2, the product, and then finally to grams of N2. For the other one, I'll show that in a minute, but we're going to do the exact same thing. We're just going to start with this. So we're going to have N2H4 here and N2H4 here, but the end part is going to be the same. So in this case, we have 50 grams of N2O4. To convert it to moles, we need to put the molar mass on the bottom. Conveniently, the molar mass is provided to us. So we get the 92.02 grams of N2O4 on the bottom, and on top, 1 mole of N2O4. We now need to convert from moles of N2O4 to moles of N2. Always when you're going from moles of one thing to moles of another, balanced chemical equation. So in this case, we want to use this stoichiometric coefficient on the bottom. So we want to put 1 mole of N2O4 on the bottom, and on top we want to put our 3 moles of N2. Then finally we want to convert to grams of N2 using the molar mass of N2, which is not provided, but since it's just N2 you could just double 14.01 from the periodic table, and you put 1 mole of N2 on the bottom and 28.02 grams of N2 on the top. Note that you do need to double it because it is N2. So you don't want to use 14.01 here, you want to use 28.02. When you do all that math, you find to 3 sig figs that you have 45.7 grams of N2 formed. Now the question becomes, is this the amount of N2 that you're going to form? Well, the answer is maybe. What we need to do is we need to see what happens if we use all of our N2H4. And if we use all of our N2H4 and we make more than this, then this is how much we're going to form. If we make less than this, then we're going to form however much we make with our N2H4. So in this case, we want to go from grams of N2H4 to moles of N2H4 to finally moles of N2, and then I guess I should say finally to grams of N2. So the end part is the same, but the beginning part is different. So in this case, we're starting with 45 grams of N2H4. I want to convert to moles. Well, conveniently, I am given the molar mass, so I put the 32.05 grams of N2H4 on the bottom and the 1 mole of N2H4 on the top. Then the next thing I need to do is I need to convert it to moles of N2. Just like before, I need to use the balanced chemical equation, but note this conversion factor is not the same. In this case, I want to put the 2 moles of N2H4 on the bottom and 3 moles of N2 on the top. In the last case, I'm going from moles of N2 to grams of N2, moles of N2 to grams of N2. Same conversion factor. Said another way, I could just copy this down here. So 1 mole of N2 on the bottom and 28.02 grams of N2 on the top. And when we do all that math, we get 59.0 grams of N2. So what this means is if we use all 50 grams of our N2O4, we make 45.7 grams of N2. If we use all 45 grams of our N2H4, we could make 59 grams of N2. Well, how much are we going to make? we're going to make whichever one's last, because in both cases, we're calculating how much we can make if we use all of it. Said another way, once we make this much N2, this is gone. We can't make any more N2. So this is what's called the theoretical yield. This would be called the limiting reagent. So the limiting reagent is the chemical which makes less product. The theoretical yield is the mass of product that is formed from that amount of that reactant. So if we check our answers here, okay, the limiting reagent is N2O4, and the theoretical yield is 45.7 grams, which is choice letter D.